got left, I'll take any other questions. But this one is going to be kind of lengthy because there's 3 graphing problems. I assume you guys want to go through all 3?
Yeah.
Alrighty. So first we want to know about period. This is going to be a sine graph. What is the period for the parent sine? How far until we start to see complete repetition? What'd you say? Not 2 rotations. 2 pi. 1 trip around the circle. And then when we take another trip around the circle, all the values would repeat. So period of the parent is 2 pi. We want to divide that by the absolute value of b. Where is b?
That's the 2x.
Yes.
So
there's b. Yes.
Oh my gosh.
So we do 2 pi divided by 2. So the period for this is going to be pi. Useful information because, between this information and my left and right endpoints, that'll tell me what I need to count by on my x-axis. Horizontal or phase shift. This is going to be the exact same thing as your left endpoint. We're talking about how far left or right it's been shifted. That is our left endpoint. And the only thing you would need to stick on here is whether it's going left or right. So for left endpoint, we're going to set it equal to 0 because the parent sine graph, we start at 0 radians for the parent. Then I take everything inside the parentheses, 2x plus pi. I'm going to set that equal to 0. I obviously don't have enough room in this little box to do this, so I'm going to bring that down here. So 2x plus pi equals 0. So I'm going to subtract pi from both sides. (2x) equals negative pi. I'm going to divide both sides by 2. So x equals negative pi over 2. There's my left endpoint. So if my left endpoint has changed from being 0 to now being negative pi over 2, which way did I go? Left. How far? Half of pi. So my phase shift would be left pi over 2. Vertical shift. How far up or down did it go? This is my k value. Yes. We went up 1. Asymptotes. Does the sine graph have asymptotes? Nope, then I don't have to worry about that. I'm just going to write none. X-intercepts. For x-intercepts, we're going to have 0 equals negative 2 sine 2x plus pi plus 1. I'm going to have to come and do that down here. So I'm going to subtract 1 from both sides. Then I'm going to divide both sides by negative 2. So I have 1/2 equals sine of 2x plus pi. Where on the unit circle is sine equal to 1/2? Where on the unit circle is sine equal to 1/2?
Quadrant 1, and it's going to be
Pi over 6. Okay, so we have 2x plus pi equals pi over 6 plus 2 pi n, because every time I go around the unit circle and I stop with something that is coterminal with pi over 6, it is equal to 1/2. Where else on the unit circle is sine positive 1/2? Quadrant 2.
11. Or no.
5 pi over 6. So 5 pi over 6 plus 2 pi n.
Wait, so why did we do the sine?
Sine 1/2.
They're on opposite sides.
Hmm?
They're on opposite sides. Oh, wait.
That doesn't matter. You can just switch them around. It's fine. So sine is equal to 1/2 at these two. So I take what's inside the parentheses, this right here, and I set it equal to those two locations on the unit circle. And then I have to add plus 2 pi n because I want to grab every single x-intercept. So now we're going to solve this for x. I'm going to subtract pi from both sides. What is pi over 6 minus pi? Negative 5 pi over 6 plus 2 pi n. And then I'm going to divide both sides by 2. So x is equal to negative 5 pi over 6 divided by 2. What is negative 5 pi over 6 divided by 2? Negative 5 pi over 12 plus 2 pi n divided by 2 would just be pi n. So one of the spots where I'm going to identify x-intercepts is negative 5 pi over 12 plus pi n. Since it's an x-intercept, the y value would be 0. And then we have to go through the same process over here for 5 pi over 6. So I'm going to subtract pi from both sides. What is 5 pi over 6 minus pi? Negative pi over 6 plus 2 pi n. Divide both sides by 2. So x would be what? Negative pi over 6 divided by 2? Not negative 1/3. I have negative pi over 6 divided by 2. Negative pi over 12. Plus pi n. So this is the x part of the ordered pair. Yep. So negative pi over 12 plus pi n, 0. For y-intercepts, this one I think is easier. Y-intercepts, we are going to substitute 0 in the place of x. So it's going to be 0 something. So I have y equals negative 2 sine of 2 times 0 plus pi plus 1. 2 times 0 is what? 0. So I have sine of pi. What is sine of pi? 0. Negative 2 times 0 plus 1. 1. So 0, 1 is my y-intercept. And last but not least, amplitude. How do I find amplitude? The one in front. It's the absolute value of a. So absolute value of negative 2. So my amplitude is 2. All right, I have my left endpoint. I don't have my right endpoint. How do I find my right endpoint? For left endpoint, I set this equal to 0. Set it equal to 2 pi. So right endpoint, we're going to set it equal to 2 pi. So 2x plus pi equals 2 pi. I'm going to minus pi from both sides. So 2x equals pi. Divide both sides by 2. X equals pi over 2 is my right endpoint. All right. Help me out here. There's two different things we need to determine before we can actually start getting any points down. One is what we're going to count by on the x-axis. To figure that out, I'm going to look at where my left endpoint is. I'm going to look at where my right endpoint is. And I'm going to look at my period. And then I also need to know what sine looks like. What does the parent sine graph look like? Looks like an S on its side. Starts at 0, because sine of 0 radians is 0. Then it goes up to its maximum of 1, comes back to 0, goes down to its minimum of -1, and then comes back to 0. So it has this kind of a shape to it. What is our A value? -2. What's that going to do to my graph? It's going to flip it. It's going to have an amplitude of 2, but it's going to take it from this and reflect it the other way. So it's going to go down first and then up. So I'm going to have 3 places where we hit our midline. I'm going to go ahead and sketch that midline in first. That's this. This is going to happen where the parent is going to be 0. And as far as what to count by, pi over 2's. So if I count by pi over 2, here's my left endpoint, here's my right endpoint. I've got to fit a whole S in there. Let's count by pi over 4's. That gives me a little bit more room to get this S shape in there. All right. So count by pi over 4's. So pi over 4, pi over 2, 3 pi over 4 pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, 2 pi. I'm going to go backwards just far enough to see where my left endpoint is. How many full periods do we need to graph? 2 full periods. You have to graph 2 full periods here so that we can see the pattern repeat itself. We're going to see this pattern repeat itself here. All right. Sine starts at 0, and then we said because of the reflection, it's going to go down instead of up. My left endpoint is going to be right on the midline. So at negative pi over 2, I have a point on the midline. The right endpoint, sine ends at 0. So my right endpoint of pi over 2 is also going to be right on my midline. What's going to happen exactly halfway in between there?
You're going to hit the x-axis.
Not the x-axis, but my midline again. If I didn't have this vertical shift, it would be my x-axis, yes.
Midline.
So we're going to hit the midline again exactly halfway in between.
And you're gonna
Normally, sine goes up first and then down, but we said this one's going to do what?
down first.
Down first and then up. So halfway in between these 2 points, so right here at negative pi over 4, we're going to go down whatever our amplitude is off of that midline. So down 2 off of the midline. So that puts my point right here. So I've got this going down and then up, and then what's going to happen?
It's going to repeat.
It's going to go up 2 off the midline, halfway in between those two, so right here. So So there's one full period. Now I just need to repeat that pattern. So it's going to come down here. It's going to go back to my midline. It's going to come up here. And then it's going to come back to the midline. How are we doing? I feel like that was a lot of work, but that's also because we had to do a lot of remembering of different pieces.
Yeah.
Do you guys want to do the cosine graph, the g of x?
Cosine
Okay.
is 2 pi 2, right? And then tan is pi.
Yes. For the parent, yes. All right, let's do part G. Period. Again, it's going to be 2 pi over the absolute value of b. What is b this time? What is our b value?
Oh, 4.
B is 4. So 2 pi divided by 4, which is going to be what? Pi over 2.
Good for you.
Remember last time when my left endpoint and right endpoint were at negative pi over 2 and pi over 2? To have enough room to get the whole graph, we decided to count by pi over 4s. Now my whole period fits in pi over 2. So we're probably going to want to count by a much larger denominator so that we have more room to see this. Horizontal or phase shift. This is exactly the same as what? Left endpoint. So I'm going to take what's inside the parentheses. 4x minus pi over 2, and we're going to set that equal to 0. So I'm going to bring that down here because I do not have enough room in that little box. 4x minus pi over 2 equals 0. So I add pi over 2 to both sides. And then I'm going to divide both sides by 4. Pi over 2 divided by 4 is pi over 8. There's my left endpoint. If the left endpoint is normally at 0, and now it's at pi over 8, which way did I go? Right, pi over 8. Vertical shift? None. Asymptotes? None.
Why doesn't this allow?
Because there's nowhere that cosine is undefined. Sine is not undefined anywhere, so it doesn't have asymptotes. Cosine is not undefined anywhere, so it does not have asymptotes. Tangent does have undefined values. So there are places where that one has asymptotes. X-intercepts. To find my x-intercepts, this is going to be 0 equals 3 cosine 4x minus pi over 2. So I'm going to bring that down here. Divide both sides by 3, so I just get 0 equals cosine of 4x minus pi over 2. Where on the unit circle is cosine equal to 0? Pi over 2 plus pi n. Pi over 2 cosine is 0, and then halfway around the circle it hits 0 again. So 4x minus pi over 2 is equal to pi over 2 plus pi n. So I'm going to add pi over 2 to both sides. What is pi over 2 plus pi over 2? Yep, 1 pi, so pi plus pi n. Divide both sides by 4. My x-intercepts are going to happen at pi over 4 plus pi over 4n. So pi over 4 plus pi over 4n, comma, 0. For the y-intercept, 0, 0. We're going to put 0 in the place of x. So I have cosine of 4 times 0. Minus pi over 2. So cosine of negative pi over 2, which is 0, 3 times 0. So I have a y-intercept of 0, 0. Last piece here, what's my amplitude? 3. Absolute value of A. So we have an amplitude of 3. My left endpoint is pi over 8. I know my period is only pi over 2. I should find my right endpoint. What do we set the right endpoint equal to?
2 pi.
2 pi. Four times 0 is 0, minus pi over 2. So I have cosine of negative pi over 2. Negative pi over 2 would be here. What's the cosine value of that? 0. So I have 0 times 3. All right, 4x minus pi over 2 is equal to 2 pi. I'm going to add pi over 2 to both sides. What's 2 pi plus pi over 2? Let's see, this would be,
That'd be 5 pi over 2.
yes. 5 pi over 2.
And then divide.
We're going to divide that by 4.
Yeah.
X is equal to 5 pi over 8.
Why are you on here?
There's my right endpoint. 2 questions for you now. Gentlemen, unless we're talking about the review, it needs to stop. If we're talking about the review, it's fine. What does cosine look like? What does the parent function of cosine look like?
Sugar.
Yes. Show choir here. Starts at a maximum, ends at a maximum, 1 and 1. In the middle, it goes down to its lowest point, and halfway in between the maximum and minimum, it's got to cross the y-axis. Or sorry, the x-axis, not the y-axis. Here's my left endpoint, pi over 8. My right endpoint is at 5 pi over 8, and my period is pi over 2. What do you think we should count by on the x-axis?
Pi over 8.
Let's count by pi over 8s. All right, so pi over 8, pi over 4, 3 pi over 8, pi over 2, 5 pi over 8, 3 pi over 4, 7 pi over 8, pi. I am going to take it backwards. Negative pi over 8, negative pi over 4, negative 3 pi over 8, negative pi over 2. I think I can go ahead and stop right there. All right. Left endpoint happens at pi over 8. Left endpoint is a maximum, right? So it goes up to 3. 1, 2, 3. So we're right here. Right endpoint happens where? 5 pi over 8. That is also a maximum. So it's going to go up to 3 as well, whatever my amplitude is. what happens exactly halfway in between there? It's going to go down to its minimum, so down to -3 down here. Halfway in between a maximum and a minimum, what happens? Hits the midline, which in this case is our x-axis, so pi over 4 and pi over 2. So here's one period of my cosine graph. And then I'm going to repeat that pattern one more time to get my second full period here. Do you guys want to do tangent and then round it out for today?
Yeah.
I mean, we might still have a couple minutes, but it's going to take us pretty close to the end. Okay. That is honestly a lot. All right, let's do tangent. What is the period for tangent? Pi. So we do pi over the absolute value of b. What is b? 1. Right here is our b value. So the period for this is just pi. Does it have a horizontal or a phase shift? Did we go left or right at all? No. Right, so left endpoint, -pi over 2 for tangent. And we don't have anything but x inside the parentheses, so that is equal to x. Do we have a vertical shift at all? Down 1.
Where did you get -5?
That is the left endpoint for tangent. I'm going to go ahead and put this on here. I'll show you guys on a unit circle if you want to see how I know that that is the left endpoint for tangent. Asymptotes. Will we have asymptotes? Yes. So let's talk about that, because this is where I get my left endpoint and my right endpoint from. If I go this way, I go up to pi over 2. What is tangent of pi over 2? So it would be sine of pi over 2 divided by cosine of pi over 2. So 1 over 0. That's undefined, so there's an asymptote there. So when I'm moving around the unit circle and I'm trying to figure out what my period is and where my left and right are, if I'm going this way, that's going to send me to the right on the x-axis, right? But I've run into an asymptote. So now I've got to come backwards, which would send me this way. Well, when I get down to -pi over 2, what is tangent of -pi over 2? Pretty much same thing, because I have sine of -pi over 2. Thank you.
3,
50.
150, not.
All right. So cosine of -pi over 2 is still 0. So I have -1 over 0, which is still undefined, which is why I have an asymptote there. Does that help with how I knew my left endpoint was going to be at -pi over 2? And so then my right endpoint, since I don't have a phase shift, will be at pi over 2. So LEP is -pi over 2. REP is pi over 2. So asymptotes I want to name everywhere we're going to see an asymptote show up. So we know there's one at pi over 2, right? Plus Every time we go halfway around the unit circle, we run into another asymptote. So you could say negative pi over 2 plus pi n. You could say positive pi over 2 plus pi n. It's wherever, like you can name the left endpoint and then how far to get to the right. Or you can name the right endpoint and then how far to get to the left. But it's that distance in between that we have to add each time. X-intercepts. So now I need to do 0 equals tangent of x plus 1. I do have room for this one. Negative 1 equals tangent of x. Where is tangent negative 1? 3 pi over 2, and then halfway around the circle again, right? Sorry, not 3 pi over 2, 3 pi over 4. You said 3 pi over 4, and I misrepeated what you said. 3 pi over 4 plus pi n. Y-intercepts, I have y equals tangent of 0 plus 1. What is tangent of 0? 0. So this is going to be 0, 1. And then what about my amplitude? 1. Absolute value of 1. So my amplitude is 1. What should we count by? Pi over 4s, I like it. So pi over 4, pi over 2, 3 pi over 4 pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, 2 pi, negative pi over 4, negative pi over 2. We have asymptotes at pi over 2. I know I've got another one at negative pi over 2. Since we're counting by pi over 4s, that would be every 4 spaces over after that. 1, 2, 3, 4. So there's going to be another one over here at 3 pi over 2. What does tangent look like?
The
Cubic.
Yeah, it almost looks like a cubic. Does it start high or does it start low?
It starts low
Starts low,
and then
curves through, and it
does
ends
a
high.
cotangent go the other way?
Cotangent goes the other way, yes. So halfway in between my asymptotes, we're going to have a point right on the midline. To the left of that point, halfway in between the point on the midline and the asymptote, we're going to go down whatever our amplitude is.
Why did we go down?
Because it starts low.
No, I meant the midline.
Why did the midline go down? That's that minus 1 in our function. That's this right here. All right. So here we are with this. Halfway in between the point on the midline and the right asymptote, we go up whatever our amplitude is.
Wouldn't our y-intercept be 0?
Yes, thank you. Because we subtract 1 from both sides. Thank you for catching that.
Thank you, Rowan.
Wait a second. What did I do wrong? Tangent of 0. Oh, that's what I did wrong. I wrote plus 1 and it's supposed to be minus 1 because the original function is tangent of x minus 1. We're going to repeat the pattern. Halfway in between the asymptotes, we have a point on our midline. Halfway in between the point on the midline and the left asymptote, it goes down whatever your amplitude is. Halfway in between the point on the midline and the right asymptote, we go up whatever our amplitude is. So here's my second full period. That was a lot. Questions that I went over in first period today, and I will be posting the video for that, so if you want to watch those, just so that we can kind of save some time in class on Monday. I did number 1 and number 2 in first period. I did number 9 and number 13. I did number 8, part E. And then I did number 20, part E. So those are the ones that will be on the video for first period. I will have that labeled on Canvas so that you know exactly which problems were covered, so that you can watch the videos for those problems if you need to. Answer keys should be up no later than 5th period today. Like I said, I've got 1 problem left to key out.
What day is our final?
Your final exam in here is on Tuesday. If you have not brought your textbook yet, please bring that on Monday. I see you guys on Monday. We'll have one last day to review. This will be the first final exam of your day on Tuesday. Remember, the IU final, they get to sit for 2 hours. We only have 90 minutes.
What else is on Tuesday?
All your evens, 2, 4, 6. If you do not finish in 90 minutes, which is perfectly fine, you get 2 full hours to finish this exam. If you don't finish it in the time that we have for second period final, you can come back during 5th period. You'll already be done with that final exam. You can come sit for the other half an hour.